Okay, welcome to the Unit 3 review presentation. And our first problem, we're going to solve and graph each inequality on a number line. So these are inequalities in a single variable right here. All right, so first thing, let's solve. Okay, well, hey, there's a few steps here, but nothing bad. How about on the left, let's distribute that 3. All right, so that would give me 3 times 8, 24. 3 times negative 4x, negative 12x is less than, nothing to do over here on the right, so let's just write it. All right, now there are several directions you could go. I'd kind of like my x's to be positive, so I think I'm going to add 12x to both sides, leaving a 24 on the left, and then I have this 9, but then I have the negative 7x plus 12x for 5x's. Okay, now let's subtract 9 from both sides. 24 minus 9 is 15, is less than 5x, and divide by 5. So 15 divided by 5, 3. 5x divided by 5x, so x is greater than 3. Let's go and do our graph right now. Here's my number line. The key number on that number line would be a 3. And with no equal sign, with my inequality symbol right there, my dot would be open. And make sure you read from the variable, x is greater than 3. So that'd be everything to the right. All right. B. Well, there's some ugly fractions here, and you could distribute and do that and get there. I think I'd like to get rid of the fractions altogether. All right. So what I'm going to do is take this entire inequality, and since I have a divisor of 3 and 4, what if I multiplied the whole thing by 12? Then my divisors will cancel and I won't have any fractions. So check it out. Well, what's 1/3 of 12? That would be 4. So on the left, I'm going to distribute a 4 to get 4x minus 12 less than or equal to. And over here, well, 4 goes into 12 3 times, so I'm going to distribute a 3 to get 3x minus 6. Okay, cool. Now, how about we subtract 3x from both sides to get 1x minus 12 is less than or equal to negative 6. One more step, let's add 12. So x minus 12 plus 12 is x is less than or equal to 6. And let's graph this one. What's the key number on that number line? It's going to be a 6. Look at my inequality. Do you see the equals? I need a solid dot. And x is less than or equal to that 6, so my arrow will go to the left. All right, there we go. Solving and graphing inequalities in one variable. All right, now solve and graph each inequality on a number line, and this is absolute value inequalities. All right, very cool. So we can do these algebraically or geometrically, and we'll do it both ways here, just so you see both methods. So solve and graph. Here's the algebraic method that you received for this many years ago in algebra, all right? So I look at my distance from x to 3 is less than 5. Here I am right here, all right? And what am I going to get? A double inequality, and I have the opposite of c on the left, which would be negative 5, and then I have what is within my absolute value grouping symbols, x minus 3, is less than the c, which is the 5. And now I just solved this double inequality by adding a 3 to all 3 sides. So negative 5 plus 3, negative 2. X minus 3 plus 3 is x, and 5 plus 3 is 8. Now I could graph that immediately right now, but I want to show you guys that if we had done the geometric method starts you with your graph and then you go to the inequality. The algebraic method, we go from inequality to graph. So geometric method now. And remember how I said this right off the bat. The distance from x to 3 is less than 5. So I'm going to draw a number line. And the distance from x to 3, so my number line will be centered at 3, is less than 5 units. So what is 5 units to the left of that 3? Negative 2. What is 5 units to the right of that 3? 8. And then I look, the inequality is less than, so that would be open dots. And we're talking about everything within that exclusive set right there. And look at that graph actually matches the inequality. -2 is less than x, and x is less than 8. Okay, the next one. Let's do this one graphically. Do you see the greater than? I'm going down to the bottom down there. All right, so this is going to set up two separate inequalities with an or in between them. So there's my or. And I'm going to start with x plus 6 is less than the opposite of c. So that's x plus 6 is less than -4. Or x plus 6 is greater than 4. And then you just solve each of these. So over here, I'm going to subtract 6 from both sides to get x is less than -4 minus 6, -10. And over here, subtract 6 to get x is greater than 4 minus 6, -2. And then you could graph those right now. Or again, you could go to the geometric method, which is kind of cool. And, x plus 6, I need an x minus a number. So I'm going to change that x plus 6 to x minus -6. So that tells me that my number line needs to be centered at -6. And then I am greater than 4 units to the left. So 4 units to the left would be what? A -10? And 4 units to the right would be a -2. All right, so again, now think about this with the or right here. All right, with the and, the double inequality, we shaded inside. All right, we need our two dots, and we're going to go now outside. So let's see. Less than and less than, I'll have an open dot on the -10 and the -2. And then shading outside, and there it is right there. And double check with the algebra. X is less than -10. That's what that says right there. X is greater than -2. That's what this says right there. And you do not have to do these problems both algebraically and geometrically. Choose the method that works for you. If you want to start with the inequality and then graph, go ahead. If you want to start with the graph and then do the inequality, go ahead. All right? You will either start algebraically or geometrically. You don't need to do both, but I do need the inequality and the graph. All right, part C, the absolute value of 3x plus 4 equals 4. Algebraic method, we have an absolute value equation right here. So that means with the equals, all I'm going to do is I'm going to have an or right here and two equations. The 3x plus 4 could equal the opposite of c, -4, or 4. Just like that. Now, let's solve each of these. So, let's subtract 4 from both sides. So 3x equals 0. Or over here, 3x will equal -4 minus 4, -8. Then let's divide both sides by 3. So 3x divided by 3 is x, and 0 divided by 3 is 0. X equals 0. Or let's divide both sides by 3 over here and get x equals -8/3. And then I could graph both of those. Let's do one more geometrically. And now I typically would not do something like this geometrically because there's some extra steps there, but I want you to see it. I know you guys could do a number line right now and just graph those 2 points. But let's look at the geometric. Okay, I need an x, not a 3x, so let's factor the 3 out. Now, 3 times x is 3x, but then I have this minus here for my minus a number, and I have a 4. So, don't I need to make this parenthesis -4/3? Minus a negative gives me the plus, and then 3 times 4/3 gives me the 4. So there it is. Not that bad. Now let's take this and divide both sides by 3. And over here, 4/3. All right, and there we have it. Now I can do my number line, centered at -4/3. And then I have to be 4/3 to the left of -4/3. That would be -8/3. And then I need to be 4/3 to the right of -4/3 to be a 0. And an equal sign, I have solid dots. And this is the graph. X equals 0. and x equals -8/3. Now obviously you could have gone right from the algebra to the graph, but I did want you to see this geometric method one more time. All right, one more. This one's kind of an ugly one too, so let's just do it algebraically. Less than. Down here. Okay, so now opposite of c is less than ax plus b less than c. So let's think about that. My c is a 2, so the opposite of that c would be -2. What's inside the absolute value? 7 minus 5x is less than or equal to the 2, the c. Now, let's solve this double inequality. So I'm going to have to subtract 7 from all three sides. So -2 minus 7 more, -9. 7 minus 7 is 0, -5x. And 2 minus 7 is -5. And now we're going to need to divide both sides by -5. All right, now remember, when we multiply or divide an inequality by a negative number, we have to reverse the orientation of our inequality symbol. So these less than or equal to's will become greater than or equals to. And then -9 divided by -5 is 9/5. -5x divided by -5 is x. And -5 divided by -5 is 1. Now, you can't leave a double inequality like this going the wrong direction, so let's write this like this. Read it from right to left. 1 is less than or equal to x, and x is less than or equal to 9/5. You never want to write these backwards like that. Okay? Now, let's just graph this from here. So, now when I go from the algebra in a double inequality, I have two key numbers. I have a 1 and I have a 9/5. And now I look at my inequalities. Those are both equal, so solid dots. And everything is within this closed interval right here. So I'm going to draw my line between the two solid dots. And there it is. All right, number 3. Solve each inequality. If p of x is factorable, use a sign graph. Well, this inequality is already factored, so here is our sign graph. And let's begin by plotting our zeros. Well, if I have a factor of 2x minus 1, don't I have a 0 of 1/2? And what kind of dot? Look at the inequality. There's an equals there, solid dot. Okay, and then the factor of x plus 4 gives me a 0 or a root of -4. And the factor of x minus 3 gives me a 0 or root of 3. And let's not forget that's going to be a double root because that x minus 3 is being squared. We'll get there in a second though. Now let's do a test point. Oh look, 0 is available. Let's start with the 0. So if I plug 0 into these factors, I get a negative times a positive, which is negative. Now, on either side of single roots, my sign must change. So if -4 is a single root and I'm negative to the right, I must be positive to the left. If 1/2 is a single root, which it is, if I am negative to the left, then I am positive to the right. Now this 3 was a double root, so to the right of that 3, well, I'm positive to the left. I must stay positive on the right. There you have it. Okay, now greater than or equal to, I'm looking for the pluses. Right here, and then right in this interval. Oh, let's go ahead and write this down. That would be x is less than or equal to -4. And then this interval, as well as this interval. All right, so isn't that just x is greater than or equal to that 1/2? And there you have it. Part B. We better factor this one. Okay, well, it's either going to be a 2x and a 2x or a 4x and an x. And I see the -6 and the 5. I'm thinking 4x and x. Let's give it a shot. Okay, I need a product of -6 now. All right, let's think carefully. Maybe a 6 and a 1. Can I make this a 6 and then a -1 there? Oh, I don't know if that's going to work. I got to do the 3 and the 2, don't I? Let's see. How about, this was a tough one. How about a minus 3 and then a 2? Yeah, I think so. Minus 3 here and a positive 2 right there. Now let's double check. I had to think a little bit. 4x times x, 4x squared. Negative 8x, or positive 8x minus 3x would be 5x's. And negative 3 times 2 is negative 6. There it is. So it's factored. Let's go to our number line. A factor of 4x minus 3 gives me a root of 3/4. Right there. And notice the open dot because less than. And then a factor of x plus 2 gives me a root of negative 2. Right there with an open dot. Now let's use 0 as our test point. And if I plug 0 into my two factors, I get a negative times a positive is negative. And these are both single roots, so that means my sign changes between the roots. So on the left, I'm going to have to be positive, and on the right, I'm going to have to be positive. All right. Now, less than, well, I'm just looking for the minus. And here it is right there, so there's my interval right there. And let's go ahead and write down this double inequality then. Okay, notice less than's because of open dots, and I'm at a negative 2 is less than, and then everything here would be, those are all x's, and x is less than, what's that number again? I better look over here, it was 3/4. And there you have it, negative 2 is less than x, and x is less than 3/4. Man, I don't know about you, but I'm having fun. All right. Oh, we're going to have to clean up this one too. So first thing I'm going to do is get this into cubic form. Let's get everything over there on the left. So I have 2x cubed minus x squared, and then subtract the x is greater than 0. Now, this trinomial, well, there's a common factor in each term of x. So let's factor that x out. X times what is 2x to the third? That'd be a 2x squared. Times what is negative x squared minus x times what is negative x? That'd be a what? Negative 1. And now I'm hoping this quadratic is factorable. Let's see, 2x squared, I need a 2x and an x, and then I need a product of negative 1. Where's the negative going to go? All right, looks like I have a positive 1 and a negative 1. So I'm factored. Let's post our roots. Greater than, these are going to be open dots at 0. And then an open dot at negative 1/2. Oh, that's going to be tight. My big dot. Oh, there we go. A little interval there. And then an open dot at 1. Now, I can't use my favorite test point 0, so I can pick any other number I want. I did a negative 1. Yeah, that makes sense because my first favorite is 0. Guess what? My second favorite is 1, and my third favorite is negative 1. Only the negative 1 was available as a test point. Okay, let's plug those in. Negative, negative, negative. A negative times a negative times a negative is negative. And these are single roots. Nothing's being squared, so that means in between I must be positive, and then negative, and then positive. All right, greater than, I'm looking for the positives. All right, that's my little interval right there with my big dots. All right, but I know what it is. And then over here. All right, oh, let's write down my double inequality. What was that open dot? That was negative 1/2 is less than, and these are all my x's in there. X, and x is less than the 0. And now let's go do this one. There we go. That's a little cleaner right there. So that would be x is, well, open dot going to the right, greater than what number? 1. There you have it. And then part D. Oh, D, we have a discontinuity. Okay, so first let's plot our roots. A factor of x minus 6 is a root of 6, and there's an equal, so that's a solid dot. A factor of x plus 1 gives me a root of negative 1 with a solid dot. Excuse me. Now, x minus 3 is a factor in the divisor. That does not give me a root. That gives me a discontinuity. Because if x is 3, I'd have a 0 squared in my divisor, and I cannot divide by 0. So because 3 is a discontinuity, I have to do that as an open dot. Just like that. And the double thing doesn't apply to that open dot. I'm going to actually have to check both sides of that. All right. But I can still start with my favorite test point, 0. So if I plug a 0 into all three of these factors, I'm negative, I'm positive, and I'm positive, negative. All right, well, let's deal with the single root, this side. This -1 is a single root. I'm negative to the right. I must be positive to the left. Now, this is a discontinuity, so I have to check a test point over to the right of that. So I'm going to use that 4 right there. Negative, positive, positive, that's negative. So I'm negative on both sides of the discontinuity, and the 6 is a single root, so I have to change sign over there, so I'm going to be positive right there. And less than or equal to, I'm looking for the negatives. That would be from there to there, and then don't lose that open dot, from there to there. Now, what's the most efficient way to write this? You could write this as 2 separate double inequalities, but the cool people will do this. -1, note close dot, less than or equal to all my x's, and x is less than or equal to, I'm going less than or equal to because I'm going all the way to the 6. And then I just have to say, note the comma right there, what number in this interval can x not equal? X cannot equal 3. There you go. Great problem. Okay, number 4, writing. Describe the set of points that satisfy the inequality y is less than 2x minus 5. Writing. Well, I'll tell you what. I'm going to verbalize what I would write, but honestly, if you have a question like this, a picture is worth 1,000 words. So if you can graph that inequality perfectly in the coordinate plane, I will give you full credit. Now, if you want to write it out, that's fine with me. And let me verbalize that. All right? Well, y is 2x minus 5 would give us a boundary line. And that boundary line would have to be dashed because there's no equals in my inequality symbol. And then because y is less than that boundary line, I would shade below the dash line. That's all there is to it. Now, let's draw a picture of that. So I have a y-intercept of -5. Okay, 1, 2, 3, 4, 5. Right there. Now, dots don't matter because I'm looking at boundary lines being dashed or solid, all right? So, you know, some people will put an open dot right there because of the less than. But again, we're going to look at the line, not your dots when you're graphing in 2 dimensions. Okay. Anyway, we have a slope of 2, so let's go up 2 and over 1. Let's put another point right there. That could be solid or open, whichever you want. But the key is the line. Because of the less than, I'm going to put a dash line through those 2 points. Just like that. Now, there's my boundary line, and y is less than that boundary line, so I'm simply going to shade below it. Just like that. And there's my picture worth 1,000 words. Number 5. 2 minus 3y is greater than or equal to 3x, so we better solve for that y right there. Okay. So I'll probably start this by simply subtracting 2. So I have 2 minus 2 is gone, negative 3y, and then on the right I have 3x minus that 2. Then let's divide everything by -3. And remember, when we divide by a negative, we've got to flip our inequality symbols, so greater than or equal to becomes less than or equal to. Now, -3y divided by -3 is y. Y is less than or equal to 3x divided by -3 would be -x, and -2 divided by -3 would be plus 2/3. All right, let's graph it. So my y-intercept is 2/3. Let's do our best here. I don't know, about right there. Okay, and our slope is -1, so let's drop 1 and run 1, about right there. And again, Dots don't matter here. I'm looking at your line now. Okay, less than or equal to, that's going to be a solid line. And now y is less than or equal to this boundary line, and everything below that boundary line would be this region right here. Oh, this is fun. All right. Now, if you just look at this and see the absolute value of x is less than 3, you think you're graphing on a number line. But make sure you read the problem. Graph each inequality in the coordinate plane. So that tells me I have 2 dimensions. I need a coordinate plane. Now, the absolute value of x is less than 3. Well, if you see that geometrically, you just know the distance between x and 0 is less than 3. All right, and you can do that right now. Or you could do it algebraically right here, where x, well, which one am I looking at? Less than. So negative 3 is less than x, and x is less than 3. There it is right there. So one more time. The opposite of c, negative 3, is less than whatever is within the absolute value, x, and that is less than the c, or the 3. So think about the lines for x equals a number. Those would be vertical lines, right? And because there's no equals, they're going to be dashed. So I'm going to say a dashed line at negative 3, a dashed vertical line, and a dashed vertical line at positive 3. And then x can be any x in between the negative 3 and the positive 3, anywhere in the plane. So I've got to shade everything in between those 2 dashed vertical lines. And there's that graph. That's a great problem. All right. Oh, a system. Right on. Okay. Let's go x is greater than 0. So think the boundary line would be x equals 0, but that's going to be dashed. So x equals 0 is the y-axis. Okay, and then x is greater than that boundary line, so that would be everything to the right. Okay, there's my first inequality. Now the second inequality, how about we just solve for y real quick? So let's subtract 3 x's. So we have 4y is less than negative 3x plus 2, or if you like 2 minus 3x, that doesn't matter. And then let's divide everything by 4 now. So 4y divided by 4 would be y is less than negative 3x divided by 4, negative 3/4 x, plus 2 divided by 4 plus 1/2. Y-intercept is 1/2 right there. And again, solid or open doesn't matter here. I did open. Okay. Slope of negative 3 over 4. Okay, let's do this carefully. Negative 1, negative 2, negative 3. And then 1, 2, 3, 4, right out there. All right, now what I'm looking at is not your dots. All right, less than. I want a dash line through those 2 dots. All right, now y is less than this boundary line right here. So that would be everything below that one. So I'll do this region in another color. And then I have to think to myself, looking at this, what is the double shaded region? And wouldn't that be this region right in here? So let's really highlight that region. There we go. That's great. And there's my graph. All right. Oh, another system. Very cool. All right. This is a parabola and then a line for boundary lines right here. So let's start by graphing the boundary line for the parabola. So can I factor x squared minus 2x? Common factor is x. X times, well, x times x is x squared, and x times what is negative 2x minus 2. So my roots are 0 and 2. 0 and 2. Roxy, I'm recording right now. Thank you. Hey guys, just a second. There's somebody at the door. Let me let the dog out. I'll be right back. Come on, Rox, go.
Guys are here to work.
Yeah, I'm recording right now, so they'll have to be in the other bathroom for a second. Okay, I'm back. I am so sorry. Welcome to the real world and remote teaching at home. Okay, so there's my roots of my boundary line that will be a parabola. And isn't the axis of the parabola going to be the vertical line right between the two roots? So wouldn't the axis have to be x equals 1? Now, and again, if you don't remember that, you know the axis is x equals negative b over 2a. So I go up here and go, the opposite of negative 2 would be 2 over 2 times 1. That's 2 over 2, and that is a 1 there too. All right, so now the vertex. Well, where's the vertex? Y equals, well, if I plug that 1 into either up top or down here, I'm going to get my y coordinate. Let me see, 1 times negative 1, that'd be a negative 1 right there. So my vertex is going to be when x equals 1, y equals negative 1. That is right here. Okay, so now what is this boundary line? Is it solid or dash? Greater than or equal to? This is going to be a solid, so I'm going to do a parabola going through these 3 points. Okay, solid. Now, my boundary line that is linear, the y-intercept would be a 6. 1, 2, 3, 4. I'm out of room. I'm not going to panic. 5, 6. I'll approximate. And the slope is negative 1. So I'm going to drop 1 and run 1. About right there. Okay. And now draw the line through those 2 points. And that also will be a solid line. And now think, where's my shaded region? Well, I have to be greater than the parabola and less than the line, so that's going to be the region right in between. Greater than the parabola and less than the line. Right there. Okay. Number 7 then. Give a set of inequalities that defines the shaded region. All right, well, look at the boundary lines of the shaded region. Okay, well, I've got to be above that horizontal line, so that'd be x is greater than or equal to. All right, and what is that? Well, the y has to be greater than or equal to 2. Okay, again, so that is everything above this horizontal line, including that horizontal line. And now I see 2 vertical boundary lines. So think about that like the problem we did earlier. The absolute value of x was what? Less than 3. All right. So now this would be, well, let me see. X would have to be between 1 and 3 inclusive. So that's going to be 1 is less than or equal to x, and x is less than or equal to 3. And that's everything in that region right there. And now I have one more boundary line. And this won't be quite as easy because I'm not horizontal or vertical, so I have to have 2 variables here. And I only know those 2 points right now, so I'm going to go point slope. And there it is. Y minus y sub 1 equals m times the quantity x minus x sub 1. So what's my slope? Well, to get from this point to this point, I'm going to drop 1 and I'm going to run 2. So I see a slope of negative 1/2. And then I can use either point. I'll use this first point right here. So let's go to my equation and let's just clean this up right here like that. Now, first thing I'm going to throw in here is my slope. All right, negative 1/2 would go right there. I might have put the point in first. I don't know. I did, yeah. Look at this. So y minus y sub 1. Well, the y coordinate of the point I'm using is 4, so that's y minus 4 equals my slope, negative 1/2, times the quantity x minus the x coordinate of the point I'm using, which is a 1. And now that's the boundary line right there. All right, but now I've got to write this as an inequality. So I'm going to go y is, and it's everything below this boundary line, less than or equal to negative 1/2 x plus 1. And you guys see how I took this minus 4 and added it to the other side? So I'm going to say y is less than or equal to negative 1/2 times the quantity x minus 1 plus 4. And there's my boundaries right there. Hey, I'm sorry for all the interruptions. I have dogs going crazy. I have people working on a remodel of my bathroom, so it's going to get a little crazy. I just have one more recording to do, and we'll be good to go. All right, believe it or not, this is our last problem. Look, the big old story problem to finish up. And this is way more, it looks way more intimidating than it really is. This is nothing more than linear programming. So let's read carefully and set up some inequalities and then do a little graph and see if we can find some corner points. And it looks to me like we're going to be maximizing some profit right here. So cars and trucks are made in a factory that is divided into two shops. Shop 1 performs the basic assembly operation, working 6 person days on each truck and only 3 person days on each car. Okay, so I'm going to say X is the number of trucks, Y is the number of cars, and there's my 6 person days on each truck and 3 person days on each car. And then I better read a little more. Shop 2 performs finishing operations, working 4 person days on each car or truck that it produces, and then shop 1 has 150 person days per week available. All right, so I'm going to use these 3 highlights to set up my first inequality. Okay, so let's think. X is the number of trucks, 6 person days per each truck, that's a 6X, 3 person days for each car, that's a 3Y, and it's available for 150 person days per week, so that would be, we've got to be less than or equal to 150. There's our first one. Now, I already read this part, but let's read it again. Shop 2 performs finishing operations, working 4 person days on each car or truck that it produces. And then let's get to shop 1 has 150 person days per week available, while shop 2 has 120 person days per week available. So I can use this lighter red highlights to come up with my second inequality, or my second constraint right here. So 4 person days on each car or truck. Well, wouldn't that just be a 4x plus 4y? And then has 120 person days per week available, so that's less than or equal to 120. And there are my 2 constraints. Now if I can graph those boundary lines and find my feasible region with corner points, I'm going to be able to maximize the profit. And by the way, what is the profit? The manufacturer makes a profit of $500 on each truck and $350 on each car. So wouldn't that be profit equals 500x plus 350y? Why, yes. And how many of each should be produced each week to maximize profit? So we're going to maximize profit. All right, well, let's graph our constraints. How about some y-intercepts here? Well, if x is 0, y would be 50. And if y is 0, how many times does 6 go into 150? That would be what, 25 times? 25. Now, 50, 25, I probably better scale by 5. So let's see if that's what I did. Oh yeah, look at that. So my y-intercept is 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And my x-intercept is 25. 5, 10, 15, 20, 25. Right there. And there's my first boundary line. Okay. Now, intercepts here. Well, if x is 0, 4 goes into 120 how many times? That would be 4 goes into 12 3 times, so that would be 30. Okay, so 0, 30. Well, let's do that. 5, 10, 15, 20, 25, 30. Oh, I did this first. Okay, so if y is 0, I get a 30 there too. I see why I did that. Now let's go 5, 10, 15, 20, 25, 30. And 5, 10, 15, 20, 25, 30. And there's my other boundary line. And I'm hoping we can clearly see this corner point. Because remember, we are maximizing profit. Okay, So the feasible region would be this lower part of quadrant 1 right there, and I have 3 corner points. My first corner point was, what was that again? 0, and then 5, 10, 15, 20, 20, 0, 30. And then this next corner point right here looks like a 1, 2, 3, 4, and then up 5, 10, 4, 10. Oh, I forgot I was going by fives there. Be careful, Gibbons. So that's going to be 5, 10, 15, 20, and then I'm going up 5 to 10. Yep, 20, 10. And then this one's just going to be 5, 10, 15, 20, 25. So that's a 25, 0. Okay. Not my best work today, but man, there's so many distractions going on. And I'm trying to finish up so they can work on my master bath right in here. Okay, no excuses though. What was my profit? There it is right there. So which of these points is going to maximize profit? Now I'm not going to do a table. There's only 3 points. But look at the profit if I use 0, 30. Wouldn't that just be 350 times 30? And 350 times 30. And I've got $10,500 if I use that corner point right there. Now, how about that middle corner point? Well, I'd go 500 times 20 times 20 plus 350 times 10. And I'm getting $13,500. Ooh, I like it. And then the last corner point, the 25, 0, is going to be 25 times 500. And that's going to be $12,500. So it looks to me like we're going to be doing 20 trucks and 10 cars. All right. And that is what? Every day. Yeah, that was per person days. So 20 trucks and 10 cars per day is going to maximize our profit. And that profit would be $13,500 per day. Not bad.